In the previous video, we were able to apply the binomial theorem in order to figure out what a plus b to the fourth power is in order to expand this out, and we did it. And it was a little bit tedious, but hopefully you appreciate it. It would have been useful if we did even a higher power, a plus b to the seventh power, a plus b to the eighth power. But what I want to do in this video is show you that there's another way of thinking about it, and this would be using Pascal's triangle. And if we have time, we'll also think about why these two ideas are so closely related. So instead of doing a plus b to the fourth using this traditional binomial theorem, I guess you could say formula right over here, I'm going to calculate it using Pascal's triangle and some of the patterns that we know about the expansion. So once again, let me write down what we're trying to calculate. We're trying to calculate a plus b. So a plus b to the fourth power, to the fourth power. So I'll just do this in a different color, to the fourth power. So what I'm going to do is set up Pascal's triangle. So Pascal's triangle, so we'll start with a 1 at the top. And one way to think about it is, if it's a triangle where if you started up here, at each level you're really counting the different ways that you can get to the different nodes. So 1, and so I'm going to set up a triangle. So if I start here, there's only one way I can get here, and there's only one way that I could get there. But now this third level, there are, if I were to say how many ways can I get here? Well, one way to get here, one way to get here. So there's two ways to get here. One way to get there, one way to get there. The only way I can get there is like that. The only way I could get there is like that. But the way I could get here, I could go like this, or I could go like this. And then we could add a fourth level where, let's see, if I have, there's only one way to go there, but there's three ways to go here. 1 plus 2. How are there three ways? You could go like this, you could go like this, or you could go like that. Same exact logic. There's three ways to get to this point, and then there's only one way to get to that point right over there. And so let's add a fifth level, because this is actually what we care about when we think about something to the fourth power. This is essentially 0th power, binomial to 0th power, first power, second power, third power. So let's go to the fourth power. Fourth power. So how many ways are there to get here? Well, I just have to go all the way straight down along this left side to get here. So there's only one way. There's 4 ways to get here. I could go like that. I could go like that. I could go like that. And I can go like that. There's 6 ways to go here. 3 ways to get to this place. 3 ways to get to this place. So 6 ways to get to that. And if you have the time, you could figure that out. There's 3 plus 1, 4 ways to get here. And then there's 1 way to get there. And now I'm claiming that these are the coefficients when I'm taking something to the, so this is if I'm taking something to the 0th power. This is if I'm taking a, well, not something, a binomial to the first power, to the second power. And you might, obviously a binomial to the first power, the coefficients on a and b are just 1 and 1. But when you square it, it would be a squared plus 2ab plus b squared. If you take the third power, these are the coefficients. Third power. And the fourth power, these are the coefficients. So let's write them down. The coefficients I'm claiming are going to be 1, 4, 6, 4, and 1. And how do I know what the powers of a and b are going to be? Well, I start this first term at the highest power, at a to the fourth. And then I go down from there, a to the fourth, a to the third, a squared, a to the first, and I guess I could write a to the 0. A to the 0, which of course is just 1. And then for the second term, I start at the lowest power at 0, and then b to the first, b squared, b to the third power, and then b to the fourth, and then I just add those terms together. And I just add those terms together. And there you have it. I have just figured out the expansion of a plus b to the fourth power. A plus b to the fourth power is exactly what I just wrote down. This term right over here, a to the fourth, that's what this term is. 1a to the fourth, b to 0, that's just a to the fourth. This term right over here is equivalent to this term right over there. And so I guess you see that this gave me an equivalent result. Now an interesting question is, why did this work? Why did this work? And I encourage you to pause this video and think about it on your own. Well, to realize why it works, let's just go to these first levels right over here. If I just were to take a plus b to the second power, a plus b, a plus b, a plus b to the second power. This is going to be, we've already seen it, this is going to be a plus b times a plus b. So let me just write that down. A plus b times a plus b. So we have an a, we have a b, and a b. We're going to add these together. And then when you multiply it, you have, so this is going to be equal to a times a. So you get a squared. And that's the only way to get an a squared term. There's only one way of getting an a squared term. Then you're going to have plus a times b. So let me write this. So plus, let me write it this way. Plus a times b. And then you're going to have plus this b times that a. So that's going to be another a times b. A times b plus b times b, which is b squared. Now this is interesting right over here. How many ways can you get an a squared term? Well, there's only one way. You're multiplying this a times that a. There's only one way of getting there. Now, how many ways are there of getting the b squared term? How many ways of there getting the b squared term? Well, there's only one way. Multiply this b times this b. There's only one way of getting that. But how many ways are there of getting the ab term? The a to the first, b to the first term. Well, there's two ways. You can multiply this a times that b, or this b times that a. There are, just hit the point home, there are two ways of getting an ab term. And so, when you take the sum of these two, you are left with a squared plus 2 times ab, 2 times ab plus b squared. Notice the exact same coefficients, 1, 2, 1, 1, 2, 1. Why is that like that? Well, there was only one way to get an a squared. There's two ways to get an ab, and there's only one way to get a b squared. If you extend it to the third power, you would say, okay, there's only one way to get to a to the third power. You just multiply the first a's all together. And there is only one way to get to b to the third power. But there's three ways to get to a squared b. And you could multiply it out, and we did it. We did it all the way back over here. There's three ways to get a squared b. We saw that right over there. And there are three ways to get ab squared. Three ways to get ab squared. And if you sum this up, you have the expansion of a plus b to the third power. So hopefully you found that interesting.